All right, welcome to section 3.4. Today we're going to be looking at multiplying and dividing integers. So previously we've looked at subtracting and adding integers, which are basically the same kind of process. And so today we're looking at something a bit different. So what we're actually going to cover is obviously multiplying and dividing integers. We're also going to simplify expressions with integers and evaluate variable expressions with integers, and then ultimately leading to translating word phrases to algebraic expressions, as we've done in most other videos. So some key points when we think about multiplying integers. Two positives end up with a positive product. An example of this would be 3 times 4 would equal 12. So you can see it's positive 3, positive 4, positive 12. So now if we have two negatives, we end up with a positive product. So the negatives actually cancel. And so you could think of something like negative 3 times negative 4 would still equal 12. So this negative here and this negative here, when multiplied together, become a positive. Maybe you could think of it as if you've multiplied a negative by a negative, you end up with one of those negatives with the other one vertically through it. Whichever way you want to remember it, it's just negative times a negative becomes a positive. And so the other two options are both kind of the same. Remember, it's commutative. If we've got a number multiplied by another number, it doesn't matter which one comes first. So then when we've got a positive multiplied by a negative, we get a negative product. So you could think of 3 times negative 4. So 3 times 4 is 12, and then we've got that negative sign. We've only got one of them, so they don't cancel, which will mean that it was negative 12. Now the opposite would be a negative times a positive. So maybe this would be negative 3 times positive 4. We still actually get negative 12. So remember that multiplication is commutative. So we can move either number around. It doesn't matter the order of them. As long as there's one positive and one negative being multiplied together, you will get a negative product. So please try and remember these before we go into the examples. I'll explain as I can, but if you can just write these down, have them next to you, and then have a go on your own, you'll find this lecture a lot more beneficial. So multiply each of the following. So for A, we've got negative 9 times 3. Well, we know that 9 times 3 is 27. And then we've only got one negative, so it doesn't cancel. So we get negative 27. For B, it's negative 2 times negative 5. So remember, the two negatives will cancel, which means the result of this, or the product of this, will be 2 times 5, so we'll get 10. 4 times negative 8, well, we know it's going to be a negative product because we've only got one negative number multiplying the other positive number. And so 4 times 8 is 32. And so it'll be negative 32. Finally, we should have a pretty good understanding of 7 times 6. That's just similar to our multiplying whole numbers video. And so 7 times 6 equals 42. So multiplication by negative 1. Multiplying a number by negative 1 gives its opposite. So remember that from our last couple of lectures, we talked about opposites. I think it was section 3.1. If you need a refresher, go back there. But effectively, if you have a negative symbol and then something else in the brackets, let's say it's 4, this means the opposite of 4, which would equal negative 4. This becomes more useful if you have maybe that. So it's the opposite of negative 4, which would be positive 4, which is why these cancel. Remember, this is really a negative 1. So this is saying negative 1 times negative 4. So it doesn't actually change the value of the 4. All it does is flip the signs. And so you can see here, negative 1 times A equals negative A. So this is really what we've been talking about over the last few lectures. So the opposite of A is the same as negative 1 times A. This should kind of explain to you, if we have negative 3 times negative 4, what this is really saying is that if we have negative 3 times negative 4, we're saying 3 times negative 4 and then take the opposite of that, which would be a positive, right? And so we get 12. So a couple of quick examples. We've got negative 1 times 7, which is the same as saying the opposite of 7. So this would be negative 7. Negative 1 times negative 11 is the same as saying the opposite of negative 11, which would be positive 11. So hopefully that gives you a good understanding of that. It's really, really important moving forward that you understand this. So spend a little bit of time here practicing if you need. So now moving on to dividing integers. It's the exact same kind of process as earlier. So two positives equal a positive quotient. So as an example, if you have 3 divided by 4, you would end up with 3/4 or whatever that is in a decimal. For two negatives, having a positive quotient, it's the same kind of deal. So negative 3 divided by negative 4, you will also end up with positive 3/4. Positive and negative, so if you have a positive on top, or a positive as the first number, and then you divide by a negative, this will end up with a negative quotient. It doesn't matter where the negative goes. Some people write it up top, some people write it maybe here, and some people write it underneath. I would probably opt for either having it on top or next to. And so it's the same thing here. If we have negative 3 divided by 4, we can still write that as negative 3 over 4. So divide each of the following. So just briefly, this won't be a division lecture. So if you need some practice doing division, go have a look at one of our division videos. I'm going to get through the division quite quickly. We can't stay on the same topic all the time. So the main point here is understanding how to divide by negatives. So for A, if we've got negative 27 divided by 3, all we need to do here is 27 divided by 3, which equals 9. Now there's only one negative, so it stays negative. So that's the whole process. It's still just 27 divided by 3. We've just got to determine whether it's a negative or a positive number. So for B, we've got negative 100 divided by negative 4. So here, I would work out 100 divided by 4 first, which I know is 25. Now, is it positive or negative? Well, we've got two negative symbols. So we've divided a negative by a negative number, which means we have a positive quotient, which means that the answer is positive 25. So then division by negative 1. This is very, very similar. So it's actually the exact same thing. So dividing a number by negative 1 gives its opposite. It's still just going to be negative A. So as an example, if we have A divided by negative 1, we could then write this as A times 1 over negative 1. And like I said before, it doesn't matter where that negative sign goes. It's still just going to end up equaling A times negative 1 over 1. And 1 over 1, as we'll get to in our fraction video, so it's perfectly normal if you don't completely understand this. So negative 1 over 1 is just negative 1, which means A times negative 1, which is the same as saying negative A. And so that would be proving that this is the same as the multiplication version. If you don't get it, just try and remember that if you divide by negative 1 or you multiply by negative 1, you get the opposite. So same thing here, 16 divided by 1 is going to be 16, and then we end up with the opposite of 16, which will be negative 16. So negative 20, and the opposite of that, because we're dividing by negative 1, means that we're going to have the opposite of negative 20, which is going to be 20. So now moving into some order of operations type questions. And so we really need to remember to follow BOMDAS or PEMDAS. So we would want to evaluate brackets first if there was anything happening in them. There isn't. We also don't have any exponents. So finally, we're at multiplication and division. So we work from left to right. And so 7 times negative 2 is going to be negative 14, which is 7 times 2, and then there's one negative. So it'll still be a negative product. 4 times negative 7 is negative 28. And then we just carry the negative 6 down because nothing has actually happened to that. So then we can combine this. So from our last videos on subtraction and addition of negatives, you can see that we have a plus and a minus. Remember now that we can just consolidate this into negative 14 minus 28 minus 6. And so now what I would do would be I would, just in terms of maybe on the side, I would work out what would happen if I flipped all the signs. What would that equal? And so you would go 14 plus 28 plus 6. And so that's me just flipping from negative 14 to positive 14, negative 28 to positive 28, negative 6 to positive 6. And so 4 plus 8 is 12, plus 6 is 18. Then we carry the 1, and then we get 2 plus 2, which is 4. And so we end up with 48. Now, if we flip the signs, because realistically, we actually flip the signs the first time around. If you're having any trouble with that, go back to the addition and subtraction videos to understand where that's all coming from. But this would mean the answer was negative 48. So really, what we've done is we've found the opposite of this whole expression here, which would be where they're all positive numbers. We've flipped all the signs. We've then added those together, found out it would equal 48. Now, if we flipped or made the opposite of the answer here, so this answer, that would be negative 48, which would be the answer to the opposite problem, which is the problem we originally had. So moving on to some exponents. So negative 2 to the power of 4. So hopefully you can kind of remember this. I think it's from section 2.1. So if we have negative 2 to the power of 4, it means negative 2 times itself 4 times. And so that's what that would look like. You can put brackets around if you would like. It doesn't actually matter, but if it helps you visualize what's going on, you can. And so I would work from left to right, just evaluating one at a time. So negative 2 times negative 2, well, that has to have a positive product. And so we end up with 2 times 2, which would be 4. Now we would then times by negative 2 times negative 2, which we could evaluate here as well. And so that would also equal 4. So each of these independently equals 4. Now we just do 4 times 4, which will be 16. So then for B, it's the same thing. But here, we don't have a bracket in the original expression. And so the first one, we said negative 2 to the power of 4, and the negative 2 was in brackets, which means both of these terms were to the power of 4, right? So the negative was to the power of 4, and the 2 was to the power of 4. So we can keep all of those and multiply the whole thing by itself. What B is just this 2 is to the power of itself 4 times, or to the power of 4. The negative is just what happens after the fact. So really what this is saying is the opposite of 2 to the power of 4, which would then be the opposite of 2 times 2 times 2 times 2. And so it's really, really important that you get where this is coming from. So just to be super, super clear, the negative in the second is not going to the power. It is only the 2. This is saying the opposite of 2 to the power of 4. So we would evaluate 2 to the power of 4 and we'd find the opposite of that. So we knew 2 to the power of 4 was 16. And so the opposite of that would then be negative 16. So you can see that notation really caused a difference in the answers. So simplify 12 minus 3 times 9 minus 12. So here we want to work on our bracket first. Remember our first thing in our order of operations. So 12 minus 3 times and 9 minus 12. What I would do here would be I would flip the signs. So I would go, how about I do 12 minus 9. So all I've done here is flip the order and change the signs of those. So you can see this was a negative 12. Now it's a positive 12. You can see the 9 was a positive 9. Now it's a negative 9. So it's being subtracted. And so this would be a 3. Therefore, the original, which would be 9 minus 12, would have to equal the opposite. So it would be negative 3. Meaning that in the brackets here, after simplifying, you would get 12 minus 3 times negative 3. And so now we do 3 times negative 3. So 12 minus, and then 3 times negative 3 would be negative 9. And so now we've got 12 minus negative 9. So remember from our subtraction videos that a minus and a minus cancel. So this would be 12 plus 9, which would then equal 21. So hopefully you're able to follow along there. I suggest doing some more practice questions outside of this lecture. So now mixing it up a bit, we've got 8 times negative 9 divided by negative 2 to the power of 3. So the first thing I'm noticing is I have some stuff in brackets, but none of it needs to be simplified except for this exponent there. And so we've got negative 2 inside brackets, which means that we're really saying, I'll rewrite the whole thing, divided by, and then that would be negative 2 times negative 2 times negative 2. So now we'll evaluate negative 2 times negative 2 times negative 2. So negative 2 times negative 2 will equal positive 4. Remember, the two negatives will cancel and we'll just get 2 times 2. And then 4 times negative 2 would then be negative 8. And so we would get negative 8. Now that would be divided by 8 times negative 9. And so now we've got 8 times negative 9 divided by negative 8, and we just need to work from left to right. So I know 8 times 9 is 72, and we've got one negative number, which means we have a negative product. So we'd get negative 72 divided by negative 8. Now here, you should be able to notice that we've got a negative number dividing a negative number, which means we have a positive quotient. And so we just have 72 divided by 8, so we'll get 9. So that whole expression would be equal to 9. So negative 30 divided by 2 plus negative 3 times negative 7. So we kind of just want to work from left to right here, doing our multiplication and division first. So negative 3 divided by 2, well, we've got one negative number, which means we'll have a negative quotient. And so 30 divided by 2 is 15. So we should have negative 15. Now there's a plus, so we don't want to do anything with that. We want to evaluate negative 3 times negative 7. So we've got two negative, which means that we will have a positive product. And so we'll end up with just 3 times 7, which will be 21. Now from our last videos, we saw when we have a smaller negative number and a larger positive number, we just flip the order so that it becomes 21 minus 15. Remember, it's commutative, so it doesn't matter. So then 21 minus 15 will equal 6. Evaluate 2x squared minus 3x plus 8 when x equals negative 4. So you probably don't know this yet, but this is actually what's called a quadratic, the 2x squared minus 3x plus 8, which you'll probably spend a lot of time on in future. And so getting used to evaluating quadratics is a very, very important skill. So all we want to do when evaluating is to plug in the number. So I always set up my equation and I just put brackets where the x's or the variables are. And so it would look like that. Then I would go back and I would substitute in my value, which will be negative 4, into those brackets where the x is supposed to go. And so now I can see that I have an exponent. So I'll be dealing with that first. So it'll be negative 4 times negative 4, or negative 4 squared. So 4 times 4 is 16, and it'll be two negatives, so they'll cancel. So we would just get 2 times 16. So then minus 3 times negative 4 plus 8. Now we can do our multiplication from left to right. So 2 times 16 is 32. And then we've got 3 times negative 4, and that will be negative 12. And then we've just got the plus 8. And so here you should see that we've got two negatives, so subtracting a negative, which would mean that we're adding, so that becomes a positive. So 32 plus 12 plus 8. From here, whatever way you want to calculate this, whether you want to use a calculator or you want to line this up in columns, 32 plus 20, so we end up with 52. The 20 was because I added 12 and 8 together. Evaluate 3x plus 4y minus 6 when x equals negative 1 and y equals 2. So here we've got to be a little bit more careful, but we'll still set up our equation with our brackets. And now we just got to make sure that we put the right variable into the right bracket. So we've got 3x first, so x equals negative 1, and then we've got y equals 2. Now we can just evaluate this. So 3 times negative 1 would be negative 3, plus 4 times 2 would be 8 minus 6. From here, you can evaluate this how you want. Maybe I would simplify this a little bit and I would say negative 3 plus and then 8 minus 6 is going to be 2. Now, what you could do is you could flip the signs. So instead of having negative 3 plus 2, you could have 3 minus 2, which would equal 1. Therefore, negative 3 plus 2 would be the opposite. So therefore, it would be negative 1. And so you would end up with this whole expression equals negative 1. Translate to an algebraic expression and simplify if possible. The product of negative 2 and 14. So whenever you're translating, you want to understand what you're actually doing. And so we're looking for a product. So we've got two numbers and we're looking for the product, which means that all we want to write is negative 2 times 14. You could have this as negative 2 bracket 14 if you prefer. Either way, negative 2 times 14, you'll know that it's going to be a negative number. And then you're just going to evaluate 2 times 14, which is 28. And so it must be negative 28. Translate to an algebraic expression and simplify, if possible, the quotient of negative 56 and negative 7. So again, we're looking for what we're trying to find. And so we're looking for the quotient. Now we've got two numbers, which are negative 56 and negative 7. So we have negative 56 divided by negative 7. Remember that this is equal to this expression. I prefer fraction form, so that's what I'm going to be working with today. And so the two negatives would then cancel out, and it would become 56 divided by 7. At that point, you can work this out whichever way you like, but I know that this would be 8. So there would be 8 7s going into 56. You could check that via multiplication using 8 times 7. And so that would be the answer there. Awesome. So that's another lecture done. We've gotten through adding, subtracting, multiplying, and dividing integers. And so some really fundamental skills there that you need to get good at. Hopefully the explanations were good and you understand, but I would recommend practicing working with negatives, including double negatives and triple negatives, like having 3 negatives multiplied by each other, and just different kind of problems, and getting your eyes on a bunch of different types of problems, including worded problems. Really, the more practice you get, the more fundamental of an understanding you'll have, and you'll be able to build off that fluently. We'll see you in the next video.